Welcome. In this video, we're going to continue to discuss the derivative as a rate of change. So consider the position function of a child riding a bicycle towards their home below. Let's describe the position, velocity, and acceleration in context. So right now, let's say this is distance away from home. So movement away from home is considered to be the positive direction, and movement towards home is the negative direction. Now at the very top here, they're furthest away from their home. Not only are they furthest away from home, but as you can see, the tangent line I sketched there is horizontal. This tells me that their velocity is 0, so they're not moving at this point. Okay, so what happens later on? For that, I'm going to sketch some more tangent lines. So here's one tangent line, here's another, and finally here's this one. Now, as you can see, this first tangent line has the least negative slope. So if you were hiking here, this wouldn't be so bad. But then as we get closer and closer to being a distance of 0 from home, and you're walking along, this tangent line gets more and more steep. That is, the velocity becomes increasingly negative as they travel towards their home. Since their velocity is increasingly negative, the absolute value of their velocity, which is their speed, is getting larger and larger. So they are actually speeding up as they ride their bike towards home. Now finally, what is happening here at the end? Well, here, if we were to sketch a tangent line here, and I should not have erased the previous one I had, we know at this point they haven't stopped. It looks like they're probably just riding past their house. Now, we do not know what the child is going to continue doing since the graph was cut off here. But when they're a distance from 0 from their house, their velocity is still becoming increasingly negative, so they are speeding up, which makes me see that they are just riding past their home. Well, what does all of this tell us about the acceleration? The slope of this tangent line is negative. So the graph of the first derivative, that is the graph of velocity of this position function, would look like this. They start off not moving, so a velocity of 0, and then the velocity is becoming increasingly negative. So that is represented by traveling down further and further negative. The slope of this line at any point is negative. That tells me that their acceleration would be somewhere around here. So their acceleration is constant and also negative, and since the velocity and the acceleration are both negative, we know that they have been speeding up the entire time, so they are accelerating the entire time. I hope the concepts discussed within this video were helpful.